We're going to jump right into this thing, steering and suspension test 9. It's from the electronic steering and suspension handout we got that I'm actually going to go over there. Okay, behind you over there is a compressor. Mr. Webb. You see that? Look up there. Look up there. It's got, see the black, wait a minute, right here. See? Right there. Give me that piece. Electronic suspension. This is an air suspension compressor. Now, I actually wrote a whole article for Motor Age about air suspension. And basically what you have here, this is a dryer, and this is the motor. And in this little compressor right here, if you ever have one of these that you can take apart, and don't take mine apart, but this one here has got a little piston in there that goes up and down. This has got a little crankshaft. It's really cool looking in there. And this, you might have heard some of these Continentals or some of these cars, it's got the air suspension going, you hear that noise and it's raising back up. Now you said that last time that black one was in here, y'all forgot to turn off the air suspension. It squatted down on the lift and you had to crank it up and wait till it pump itself up. And you can hear it going, and this thing's under the breather in those. If you take the breather out, there's a little panel under it, and this is down in there. As they got it kind of hidden. And some of the old Continentals would have an air fitting on here, where you could actually air the, it up yourself. Now there's a solenoid in here. You notice you got 3 wires going to it. 2 of them go to a solenoid, 2 of them, well, 4 wires, excuse me. 2 of them go to a solenoid, and 2 of them go to a motor. And this solenoid right here actually releases the air coming out. Now these right here are the one, they're in the top of the springs, a little air spring. And you know y'all put them springs, Daniel, yesterday on that Mustang. The springs on the air springs mount the same way. Only you don't have to squeeze them, you just let the air out of them. Got me? This looks almost like a big old fat fuel injector and all that. But remember, typically on these air suspension systems like the one we're talking about here, it has these things hardwired to ground, and the air suspension module puts power out to them, which is backwards from what you're used to. Injectors don't work that way, except on 87 and 90 Jeep Cherokees. All right. Okay, so this is the air suspension compressor. Got a little motor in there, a little piston. Okay, put that back over where it was. Now hang on to my little air spring here. Okay, so what you got here, it's got a compressor, solenoid vent valve, internal relief valve, and the air dryer is something that you can't really replace without replacing that little black one on top. Now you saw some of these little, turn that around and let me look at that again. Well, that little, see the little orange thing? You, on the other end of that dryer, you push those, that's one off of, like off of our black car, and it's just got 2 lines. Now the ones that's got 4-way air suspension is going to have 4 of those lines. You push that little orange ring and that line's supposed to, and he makes a big mess. All right, you push the orange ring, it's supposed to come out there. All right, now then, what it does is, basically, it's got a ride height sensor. And that ride height sensor is going to send signals to this little computer on this one. And so it's going to tell it when to turn the thing back on. Now, the General Motors, like on a Montana, you've seen some of those, like a van, and it's got an air suspension. It's not as elaborate. It can't talk to the scan tool or throw codes or anything like that. It's just got a little ride height sensor that does the whole job back there as it goes. It turns on the compressor when it needs to and this kind of stuff, So the air spring is the pneumatic spring. It acts like a balloon filled with air. Now, sometimes when they get a lot of miles on them, and if they're continually leaking down, and you're trying to work on some, you ever seen something going around like a lowrider? Them cars that's got air suspension on them, they're squatting down in the back, the bumper's almost dragging around. And what you got to do is, to begin with, you're going to have to check your electrical circuits to make sure the compressor runs. The compressor likes to fail. What's my rule of thumb on these systems? The part that's typically working the hardest and is in the most hostile environment is the part that usually fails. Does that make sense? If it's the hardest working component and it's in a hostile environment, it fails. Now, on Daniel's gas gauge is a perfect example. His fuel tank's in the unit. It's in a hostile environment and it's working hard all the time, right? And it's typically going to be the part that fails. That's usually the way that is. Not always, but usually. If you think in that direction, a lot of the times you'll figure out what's wrong with one quicker than the people that are, thinking it's the easy part to change. You know what I'm saying? Now, if it's cheap and easy, it's good to start there. You don't start with the most expensive component. That air compressor usually costs about $350, and they die. You got to put them on there. All right. So the control module let's see, on four-wheel drive with ride control switches the shocks from trim to soft when four-wheel drive is engaged.
False.
That's false. Okay, how do you know?
Because I've ridden a four-wheel drive. They do not have any nice cushion to them when you hit the bumps.
He's drawing from that. So that's basically. Let me find a place where I'm gonna tell you about that. Okay, hold on. Okay, now then, some four-wheel drive vehicles with ride control suspension will use the 4x4 mode switch as an input to the control module to switch the shocks from soft to hard ride when the vehicle's in 4x4. So basically, it doesn't make them soft, right? Does it make them soft?
It makes them stiff.
It makes them soft to firm, not firm to soft. It doesn't go the other way. Now, why would you want them firm?
So that way, like, you come into a ditch or something, like on a four-wheel track or whatever, you hit it, you don't want to just bottom out.
Now, Daniel, when you replaced the springs on your brother's Mustang yesterday, were those springs stiffer or softer?
The newer ones are softer.
The newer ones were softer? Really? Wow. Okay.
And that thing, the stock springs, when you hit a bump, normally it just jar you to death.
Oh, I see what you're saying. They were really. He wanted a better ride, and not better.
I mean, it improved everything.
Yeah.
But
yeah. Typically, if you've got the harder your suspension is, the better you corner, and the less likely you are to turn over. See what I'm saying? If you put, that's one of the reasons that they used to have, whenever some of the earlier SUVs had soft springs under them because they didn't want them riding so rough. Now the Mustang, you're not likely to turn a Mustang over because it's got a low center of gravity anyway. You know what I mean? But on a four-wheel drive, when it's up high, you want the suspension to be firm because you're less likely to turn it over if the body doesn't roll as much when you're in a maneuver. That's basically why they do that. Okay. All right. The off-road switch lets the driver activate the air suspension to raise the vehicle a calibrated amount. Not only are we stiffening up the shocks, and you do that, it changes a little valve inside the shock. You know, they got oil going on a shock absorber, and this is something I need to actually make this happen here. You got a shock absorber with a bunch of holes in it. All right, now, this glycerin stuff, or whatever they got in it, oil that's in this shock absorber, has got to go back and forth between these holes. It's got to be in order to get from one place to the other as the shock's working. Okay, so on the ones that's got ride control will have two sets of holes in here that when they're lined up with one another, the shock is kind of soft, and when you move it so half the holes are stopped up, it's harder. You got me? And the way they do that on those vehicles here that I would have been familiar with is they actually have got a little shaft coming down here with a little motor on it and a little position switch, and it'll flip back and forth and it changes the position of one of those plates. You got me? You understand what I'm saying? All right, so that's how that works. Now, General Motors has got some weird stuff where they can actually apply juice to it and it'll become stiffer. I mean, it's a different kind of a deal, but there's several different ways to do it. Long and short of it is, let's go on to number 2. Under what two conditions does the air suspension warning indicator usually come on?
Low air?
Yeah. Well, what I would look for there is if you turn off the air suspension switch, like you were wanting to do on that car this morning. If you flip it off so you can raise it up, you're going to see that air suspension come on. Another time when it'll come on is if it's trying to correct a ride height situation and it can't do it. If that module tells that compressor to come on, it's going to be looking at the ride height sensor. What is the ride height sensor in this scenario? What do we call this? It's a feedback loop, right? Mm-hmm. Basically, the ride height, the module is watching the ride height. It sees the ride height go too low, which basically is just a switch. It's got some, it's a kind of a digital switch in most cases. All right, it's going to say the wire that lights up telling it that it's gone too low comes in and it says, okay, I'm seeing us go too low. I'm going to turn on the air suspension compressor and I'm going to keep watching that ride height sensor. I'm also going to open the air spring solenoids, these things right here, and let air go into those springs. So I'm opening the solenoid right here at the pump. I'm opening the air springs at each spring, and I'm going to raise this thing up. Okay, now some of them have got 4 ride height sensors, and it can raise each corner of the vehicle separately. like on the Continental, like the Mark 8s and all this kind of stuff. But on this one here that we're talking about, mostly that one that he showed you the thing, it's gonna operate both the back ones together. That's just keep it simple. So it's gonna watch that one, and when it gets it up to where it's within the range, it's basically, if this top one lights up, it's too high. If the bottom one lights up, it's too low. So it wants to keep it in between there, right? But what if this top one is always lit up, and no matter how much air it lets out, it's always lit up? It's going to pop that light on and throw you a code. You got me? That's a feedback loop, and it's also got some self-diagnostic capability, which is what our electronics have been doing for about the last 25 years. Okay. Now, all right. So basically, if the air suspension shut off, or if it can't correct a condition, that's your answer for that one. Got me? That's on number 2. The air suspension control module strategy is to what? What is the focus and purpose of the primary purpose of the air suspension control module? What is it going to do? What is it there for? What's it supposed to do?
Ride height, perfect.
Control ride height. Yeah, it's actually reading the feedback. It's got outputs and it's got inputs, like all these computers. You know what I mean? And think about your engine control computer. When you learn that one, all the rest of these are a piece of cake, because it's got a lot of stuff it's got to do. But this particular one, this module here, is not looking at all that much. Now, one time, me and Sean had one that we worked on that I actually mentioned in that article I wrote, was this Lincoln that was not working. It just wouldn't correct the ride height. And we plugged the scan tool in it. You can plug it into the DLC and talk to it on a scan tool, and it'll tell you what's going on. And in our scan tool data stream, it said there was only 8 volts available at the module. And if the voltage, now listen to this, guys, it's really important. If the voltage goes low, most of these modules nowadays, ABS, engine controller, all of them, if the voltage goes below a certain level, they fold their arms and they're just like, I'm going to turn on a warning light and I'm not doing nothing until you fix my voltage. Because I got to have a certain amount of voltage to do my job. And you don't give me none to coming in, I ain't going to give none going out. That's what it says. So we got there, said, we're seeing 8 volts there. So I said, okay, Sean, we know which wire that's looking at that on. So we went and we checked it, and it was showing 12 volts there. Well, the module was misreporting its own voltage feed. So we got a $210 module from the Lincoln Mercury people, and we popped it in there, and all of a sudden that new module says, hey, I got all the voltage I need. See, it was actually seeing enough voltage, but it wasn't reporting it right. And so since it didn't think it was getting 12 volts, see what I mean? Understanding that is the key to fixing this stuff. So we put a module on there that took care of it. I started to say something a while ago that I forgot. If somebody's got leaks, let's say all of your electronics is good, your air suspension compressor is good, it'll pump up, but it's always leaking down. You pull the springs off, you air the suckers up, and you put them underwater to see if they're leaking. That's complicated, isn't it? No big deal. Okay, number 4. Did everybody get the answer to number 3? You understand what the answer was? Mm-hmm. Okay, number 4. What controls power to the compressor motor? Basically, think about it. What about the compressor relay? The relay is going to be a load carrying device. That module is not going to be strong enough to run that motor, because that motor is going to pull some amps. So you're going to bring power directly from the battery to your common terminal on your relay, and you're going to leave your normally open on your relay out to the motor, and when it energizes the coil on that relay, the module will do that. You're going to get power to that, And what if your air suspension compressor is not working? I'm going to unplug that thing, and I'm going to put it in a situation where it's trying to roll it, and I'm going to check and see if I got power there. And you need to see if it's got power that'll burn like a headlight bulb. Because if you just check voltage with a silly little voltmeter, it's liable to read something when there ain't enough there. You know what I mean? So if you put like a headlight bulb on there that pulls about 4 or 5 amps, and it'll light that headlight bulb real light, you're good. But if you got a little teeny high impedance test light or something, and yeah, it lights up my little bulb, that ain't good. You got to make sure there's current there and voltage. You can have voltage without current, All right, let's see. The acceleration signal is provided to the electronic suspension system by which electronic module? Acceleration signal is provided to the electronic suspension system. Huh? What do you think? What is it that knows when you're accelerating? Huh? Who said something? What?
I said the ABS.
Speed sensor.
Speed
Well, actually, it doesn't. What module knows that you've got your foot into it?
Throttle position sensor.
Jeez.
That's a sensor, yeah, but what's that sensor talking to? What's reading the throttle position sensor? What module? Come on, guy. When you put
You're talking about when you speeding up?
when you're putting your foot into the gas, or one of the boxes on that car, one of the electronic modules knows that you put your foot into that gas pedal. So what's the throttle position sensor reporting to? What's reading that? I think I'm making this, I'm wording this wrong or something. The PCM.
Yeah, he did say that.
I didn't hear him say it. I'm sorry. That was he's on the other side of the screen there. But you apologize. I didn't hear him say PCM. But anyway, I don't. Sometimes I don't hear as good as I should. Okay, so he said PCM. He was right. That's what confused everybody because he's already said PCM and you thought I heard it, but I didn't. Okay, Technician A says damping shocks and struts operate in the same manner. Do they?
False.
Technician B says damping shocks and struts operate differently. Now, have you ever seen a question like this where it's obvious that these guys are totally talking different smack about something, and it'll say A, B, or both, or neither? They're saying opposite things. Well, this one here is not written that way. So, damping shocks and struts. What was I talking about up here on the board? You know, damping meaning that, you know, whenever you bounce the car and you let off, it keeps bouncing. It ain't getting no damping that way. Have you guys ever seen a steering damper?
That's a no. That's
Nothing.
that thing we
It's a shock absorber is mounted to the frame and part of the steering, like on a four-wheel drive, so that whenever you hit bumps and stuff, it won't shimmy. It basically stops the shimmy before it happens, you know, before it starts to happen. So, but anyway, the Technician A is the only one right on that one there. And I'm going to show you guys a little bit of this program that I got on steering and suspension too, which is really cool. So on that one, that's Technician A only. Got me? Technician A says the air suspension system dryer is a regular maintenance item. Technician B says air passes back through the dryer during venting. Who's right about that?
B.
That's B. As you got to replace the whole compressor, you can't just get a dryer typically. Okay, like if you mess that dryer up, you just bought a compressor. You got me? Think about that. If you get crazy with that dryer and you bust it, that ain't pleasant, is it? The acceleration signal is provided by the PCM to the suspension control module to activate the suspension to do what? Now, on the Thunderbirds, the supercharged Thunderbirds that we used to see, when you really get on it, if you had over 400 pounds of braking pressure, or if you turn the steering wheel a certain, at a certain rate, real fast, like a swerve, or if you went over 80 miles an hour, the shocks got hard for cornering, make you less likely to turn over. See what I mean? And then they would get soft again whenever those conditions went away. So the acceleration signal is provided by the PCM to the suspension control module to activate the suspension to the hard damping position to reduce front end lift. So what happens when you really get on it? The front end goes up. Have you guys ever seen that commercial? Some of you might remember it, that they had about one of these Lincoln, not the town cars, but one of these Continentals. And they drive along here, and they drive up to this concrete barrier, and it touches that barrier. The roof actually touches this concrete barrier that's got a space under it. And then that car backs up, and it goes down to the other end of this test track, about 500-600 yards away. And then it comes back toward that concrete barrier at like 90 miles an hour, and it goes under it. So what they're doing there is when you get to a certain speed, the car lowers about an inch to make it more stable and to make it, cut through the wind better. But when you stop, it raises up. See what I'm saying? That's what some of this cool stuff they're doing with this air suspension,
It's like that wasn't working. That's gonna get stuck. Then somebody's gonna be in trouble.
Yeah, exactly. Well, if it doesn't work exactly right, it's gonna rip the top off the car, All right. Some air suspension systems use a blank input for height adjustment and kneel strategies. What do you think? Yeah, that's going to be transmission input. You got me? Now, what was I talking about when I said a kneel strategy? You think it's got to do that? Oh, here's something else you need to recognize too. Did you know? Let me ask you this: the engineers program these things so that if you've got the door open, it won't correct ride height.
So it won't?
No. Why would you not correct ride height with the door open?
Because you shouldn't be driving, it should be.
Well, no, I mean, even sitting still on the curb, if you got the door closed, it'll correct ride height.
Because human height varies too much?
Well, how about if you've got the door open and it lowers the car and all of a sudden your door is hung up on the curb?
Oh,
Where on the, you know, like you'll have a grassy,
that makes sense.
you know, a grassy knoll. I ain't talking about the one where the other shooter was, but you know, the grassiness, you know, when it goes down like that. So, all right, so when the 2-wire actuator is white, the shock is in the hard damping mode. It defaults to that. It's when it's off, it's in the hard damping mode. It's spring-loaded in that direction. Now, let me bust this on for a second. I got that all in question. I'm going to show you all this other stuff, so don't bail out on me quite yet, because I got to fire up this. I'm going to show you all some stuff we're going to burn in using this new program, and it's pretty doggone cool. Using this new program, and move that board there that's partially blocking that screen. I'm going to show you all something really quick. I got to do this pretty fast before Webb turns into a skeleton. He's over here about to croak. You see him over there. You know, Webb is not a classroom kind of a guy right here. All right. Now this right here is some stuff that you can actually look at on your own on this machine out here. Okay. Now watch this right here. I'm going to look at alignment. Now on this particular piece of software,